Hello, and welcome to the 5th installment of our ongoing series on how to use formic acid in animal feed for the North American market. I am Joshua Genza, the Technical Product Manager for Organic Acids in Novasil with BASF, and we're doing these videos in collaboration with our North American distributors, Balchem. So before we get too far into the specifics of what we want to talk about today with regards to poultry, let's do a little bit of a recap on some of what we've talked about in the other videos, because these topics are going to are covered in much more in depth in other videos, but they are relevant to poultry production. So in our first video, we talked about the principles of feed acidification, which is basically about how the acids work, how it is that they deliver the value that they deliver, and what that value is in kind of broad terms when applied to feed. The second video talked about the acid binding capacity of feedstuffs and why this is significant for the nutrient availability and performance of animals. In our third video, we talked about the acidification and how that relates to the current trend towards higher pelleting temperatures as a biosecurity step, either before or as a result of the new Food Safety Modernization Act, or FSMA. And in the fourth presentation, just before this one, we talked about acidification of swine feed, and we talked about the performance and particular values that we have in the context of swine feed specifically. And so this presentation, we're going to touch on some of these topics that we've already talked about, but we're not going to go into them in depth here. We're going to talk more about how these different product value dimensions relate specifically to formic acid value in poultry production. In the context of the Food Safety Modernization Act, it's worth noting that in Guidance for Industry number 245, which was released recently as a draft for public comment, in the section focusing on hazard analysis for risk-based preventative controls for food animals, they do talk about acidification as a preventative control. There's a lot of text there. It's about a page or two. It's probably worth reading. But one of the highlights is this table here where they talk about specific pH limits, either below or above which pathogens such as Salmonella or pathogenic E. coli have a hard time growing. And that gets at kind of one of the main values behind feed acidification with amoxicillin A, and that is the inhibition of bacterial growth. So like I said in previous videos, we talked about treatment of contaminated feedstuffs and diets. I encourage you to look at those videos. We also looked at support beyond the pelleting step as biosecurity control. That's in video 3. But here we're going to talk about mostly about promoting optimal animal performance as a result of improving feed hygiene through feed acidification. We're going to talk a little bit about nutrient availability, and then we're also going to look at management of problems such as Salmonella and Coccidia. So getting into the nutrient availability, what you're looking at here is data from a presentation that was made at the Australian Poultry Science Symposium in January, February of 2018. And this is a study that we did where we looked at feed acidification and pelleting temperatures and how that affected animal performance. Overall, performance was better with feed acidification. Pelleting temperature improved gain, but came at the expense of feed efficiency. But what I wanted to draw your attention to specifically for the context of this video is the improvements that we're seeing in the digestibility coefficients for things like phosphorus, nitrogen, energy components such as fat and starch, and just overall dry matter availability. And what we see here is dramatic reductions. Phosphorus goes from just over 45 to just over 55%, or almost 10 percentage point improvement in phosphorus digestibility simply by acidifying feed. And these benefits carry through. And the reason for this is that a lot of the digestive enzymes responsible for making these nutrients in feed available are, at the end of the day, more effective in a lower pH environment, and when they're not competing with as many bacteria in the gut for those nutrients. So the main takeaway that we presented at the meeting in Australia was amoxicillin A improves both biosecurity and digestibility of nutrients. Salmonella is also a problem as far as salmonella control goes, the vertical transmission. So this is some data where they looked at 0.5% formic acid in feed for breeders, and then they wanted to look at salmonella transmission vertically, and they used hatchery waste. And what they found is that over a 2.5 year period, they averaged about 15% of the hatchery waste samples they collected were salmonella positive. Whereas after they initiated formic acid treatment of breeder feed, they saw it drop to about 0.5%. So they took a chronic problem and they turned it into a sporadic problem. And so this breaking of the vertical transmission is very important, particularly for large integrators who maintain their own breeding stock. Another dimension to this is, of course, salmonella in the feed mill. Ingredients can come in contaminated, and what we're looking at here first is the salmonella levels in some artificially contaminated diets over time with graded levels of amoxicillin A, and as you can see that within about a week, the 10 gram per kilo dose is able to render that feed salmonella negative, and the 7 gram per kilo makes it sometime between 7 and 14 days. We then pelleted this feed and completely decontaminated it due to thermal processing, even at temperatures as low as 65 degrees. And then we simulated a recontamination post-pelleting, which can happen anywhere through your supply chain. And what we saw is that the acid being resident in that feed protected against that recontamination and continued to apply pressure to the salmonella that we'd added as that feed aged post-pelleting. So we offer both decontamination and protection against recontamination. Adkari et al. In 2017, this was some data we presented at the Poultry Show in Atlanta in 2017, and what we did in this study was we looked at feed acidification in birds that had been orally challenged with Salmonella typhimurium, and we see reductions in prevalence going from 90% down to less than 50%, Salmonella abundance going from over 3 logs down to less than 1 log, and we also saw improvements in feed efficiency, particularly in the 15 to 28 day period, which was immediately after the challenge event. Whether or not this feed efficiency improvement is a result of the challenge itself, there seems to be, due to that positive control difference. But there's also the digestibility potential that we've enhanced the availability of these nutrients, feeding that bacteria less in addition to applying pH pressure to it. And then finally, when you're looking at salmonella control, ultimately our goal for salmonella control is to keep the salmonella out of your processing facility. So this was a trial where they looked at 0.1% formic acid in drinking water during an 8-hour pre-slaughter feed withdrawal. So this is that critical period where you've taken these birds off of feed, they're starting to pick at the litter, they're starting to pick at each other's feathers, and as you can see very clearly, regardless of where the salmonella prevalence started in the summer or winter, you end up with about 50% prevalence in birds on non-acidified water and about 11 to 12% prevalence in birds fed acidified water. When you then take the next step and take these birds and take them through into the processing facility, what we saw is that in birds that had been on the control water, they had salmonella prevalence at different sites anywhere between 20 and say 35%. But then when we looked at the birds that were in the group consuming acidified drinking water during that 8-hour pre-slaughter feed withdrawal, we saw significantly lower levels of salmonella prevalence, closer to 10 to say 15%. Switching gears a little bit from salmonella into coccidia, when we talk with poultry producers, they say their #1 thing that keeps them up when they contemplate going into the no antibiotic ever market is coccidia, because this is something that you cannot eliminate from the barn and has a significant effect on performance. And so we wanted to look at whether or not how amoxicillin A compared to some in-feed antibiotics that might be used in the case of a coccidia outbreak to see how we compare. Because at the end of the day, necrotic enteritis is a result of both coccidia and Campylobacter is a bacteria which lots of data shows is sensitive to formic acid. So looking at body weight gain, we've got the negative control on the left, and then the lines show the difference between the negative control and the positive control, or the challenged groups. And we see challenged and untreated, we see significant reduction in body weight gain. We see significant loss in feed conversion going from 1.7 to 1.8. And we see a significant increase in mortality going from 2% mortality in the absence of a coccidia challenge up to 7% as a result of that coccidia challenge. And when we look at the green bar and the orange bar representing the medicated feed, we see that more or less amoxicillin A and medication in this trial delivered roughly comparable benefits. There might be a slight numerical benefit towards the amoxicillin A, but statistically, feed treated with amoxicillin A and treated feeded with BMD and Coban resulted in performance that was not significantly different from the negative control, and were not significantly different from each other, and were improvements over the untreated state. When we look at necrotic enteritis severity, we looked at necrotic enteritis lesions, and we see at both day 21 and day 42 is that, of course, there's a dramatic increase in lesions as a result of the coccidia challenge, and both Amycil and antibiotic treatment of that feed resulted in improvements in lesions but didn't eliminate the problem. They were still different from the negative control. When we looked at the oocyst counts, again we see higher counts in birds that were challenged than in the unchallenged birds, but obviously we still see a lot of oocysts in the unchallenged birds as well, because this is in the environment no matter what you do. And then we see that the Amisil and the medication ended up having similar effects, bringing oocyst counts down, which is what you want. So in conclusions, I hope the takeaway from this video is that feed acidification delivers real value, not just to the feed mill, but to poultry producers who are trying to grow those birds and maintain healthy birds every day. The value is definitely centered around the inhibition of microbes, and this is because of their susceptibility to pH manipulation. Salmonella, Clostridium have clearly been shown previously to be susceptible to formic acid and pH in general. Emeria, we're not exactly clear with the Coccidia challenge stuff how much of that's from the Clostridium control or direct effects on the Emeria, but we are seeing reductions in lesions, which are caused by the Emeria regardless of the Clostridium, and we're seeing reductions in oocyst counts, which suggests that we're directly affecting the Emeria as well. And that acidification can also promote nutrient availability. Some of this is due to enhancing the activity of the enzymes that are responsible for digesting that feed, and part of that is due to reducing competition within the gut between the host and these bacteria and protozoa that you might find in birds. So with that, I'd like to say thank you for taking the time to view this video. I highly encourage you to watch the other videos if you haven't already, and have a good day.